Welcome to 23rd lecture. We are studying electronic devices and circuits. In this lecture, we will study sub-bias JFET configuration. In our earlier lecture, we studied fixed bias JFET configuration. In this configuration, we don't have a VGG to reverse bias or to supply a negative voltage and to have a negative VGS, because this RS is serving the purpose. Using this RS, we can obtain a negative VGS. And in the output loop, we have, instead of one resistors, in our earlier lecture we had only RD. Here we have RD and RS, right? So to analyze this circuit, first we have to write input loop equation. This is the input loop equation. We start from here. The first thing that we encounter is VGS. Since we are entering from the positive side, which is voltage drop, we write it negative, minus, it's also a voltage drop. The voltage drop across RS is ISRS, because the current flowing through source resistor is RS. Since we know that ID and IS are the same, so we can replace this IS with ID. So VGS can be written as negative ID RS. So we have obtained a negative VGS with the virtue of this resistor RS, right? But to find the numeric value of VGS, we know ID, but ID isn't known. And to find ID, the other way around, we divide this by RS and then we need VGS. So they both are unknown. VGS and ID, they both are unknown. So we need one more equation, right? We already know that ID, the Shockley's equation, is IDSS 1 minus VGS over VP. If you put the value of VGS here, this equation becomes IDSS 1 minus, instead of VGS you put IDRS. We don't put a negative here because this is negative and VP, the magnitude of VP is also negative. So the negative cancels with the negative. So VP squared. So now this IDSS is a datasheet parameter. IDSS and VP are, we already know they are datasheet. They are datasheet parameters. So we already know that IDSS is known, RS is known, and VP is also known. So in this equation, we have only one variable ID which we can solve, but it's a quadratic equation. If we expand it a bit, we see this square when expanded is 1 squared minus 2 times ID RS over VP plus this whole squared ID squared RS squared over VP squared times this whole IDSS. So ID is this. You want to solve it a bit further. This IDSS can be multiplied with each of these three terms. So ID becomes IDSS minus 2ID times IDSS RS over VP. So IDSS multiplied with this term becomes IDSS ID squared RS squared over VP squared. Now this whole equation can be multiplied with VP squared to get rid of this numerator. So VP ID is VP squared ID IDSS S Vp squared minus, when we multiply Vp squared cancels 1 Vp, 2 ID, IDSS, RS, Vp plus, here this Vp squared vanishes, IDSS, ID squared, RS squared. So now we can collect the terms related to ID squared and ID. There is only one term involving ID squared. So RS squared IDSS is the coefficient of ID squared. Right? For ID, we have two terms, this and this. So when we take it on the other side, this becomes minus 2ID IDSS. Take it to the other side, plus Vp squared ID. Right, so we have written this term here, these two terms, and this constant term, plus IDSS Vp squared. And this whole is equal to 0. So now we have this quadratic equation. This is coefficient for ID squared, this is for coefficient for ID, and this is the constant term. Let me check it. Let me check it in my notes. The same answer, R squared IDSS minus 2 IDSS IDSS minus 2 IDSS RSVP. Sorry, this is SVP. This term, because ID is taken as common here. Minus 2 RTRS IDSS RSVP plus Vp squared IDSS. Now we can apply quadratic formula to find the numeric value of ID. This is generally called A, this is S, this is called P, this is C. So the formula is minus B plus minus square root of B squared minus 4 is C over 2A. So ID is now minus B is 2 RS VP IDSS plus VP squared. Minus B plus minus is whole squared, squaring this whole terms, 4 RS squared VP squared IDSS squared plus 2 times the product of these two, 4 RS VP cube IDSS minus 4 is C. A is RS squared IDSS. C is IDSS VP squared, so IDSS becomes squared and VP squared. This whole is in a square root divided by 2 times A, RS squared IDSS. Divided by 2 RS squared IDSS. So this term cancels with this term, and we are left with ID, which is 2 RS VP IDSS plus VP squared plus 4 times this quantum plus VP cube. We apply add a square to this term, so this is this square plus 2 times this quadrant plus this square. So we have 4 RS VP cube IDSS plus VP to the 4 over this 2 RS square IDSS. So everything is known here except ID. You know, RS, VP, and IDSS. Right? So we can plug these values in to all the unknowns and can find ID. So this is how we can find ID here. Another way of finding is the graphical method. We can find ID using the transfer characteristics. This is VGS, this is ID. So this value is the max possible value of ID, we call it IDSS, and it is VGS off or VP, the most negative value. So in order to have a bias point here containing this ID and then VGS, of course it's minus IDRS, we already know that VGS is minus IDRS. We just derived it from the input loop equation at the start of this lecture. So VGS is minus IDRS. So we have 2 points. When we have 0 ID, this means VGS. When we have 0 VGS, we have one of the points can be taken here. The other point, if we have another point, and we can draw a line, and then the intersection between this curve and the line will give us the bias point. So in order to find the other point, we'll see what is the maximum possible current when VGS is 0. We already know that when VGS is 0, we have the maximum possible current IDSS flowing, right? When we have this IDSS current flowing, what is VGS then? It's minus IDRS. So we'll multiply this VGS with minus, VGS becomes minus. The maximum possible current is IDSS. We have this IDSS flowing RS. So minus IDSS RS. Maybe this point is somewhere. IDSS RS is the voltage. Maybe this point is minus IDSS times RS. This is the point when we have IDSS current flowing. So when we have IDSS current flowing, the voltage drop VGS is minus IDSS RS. We derive it from input loop equation. So we have one other point here. So now we have on this curve, we have 2 points, this point and this point. If we draw these, if we connect these 2 points with a straight line, we have this point VGS Q and ID. So this is another way of finding VGS and ID. In addition to this is one way using quadratic formula. This is another way using the graph. And once we know VGS and ID, we can always write output loop equation. We can always write output loop equation to find VDS, which is simple. So finally, we can write this output loop equation, that is VDD minus IDRS minus our unknown VDS minus ISRS. Since IS and RD are the same, so we have all knowns here. This is known, this is known, this is known, and we can find the value of VDS, the bias point. In the next lecture, we'll study more biasing techniques related to JFET.